So get out your composition notebooks, and you are going to take notes today on multiplying and dividing rationals. So I'm going to do one example with multiplication and one example with division. So to start, when we multiply rational expressions, what I'm going to do is I'm going to leave like this left-hand column open because I'm going to put words here, and I'm going to start the problem just slightly over to the right. So we're going to multiply x squared plus 6x over the quantity of x plus 6 squared times x squared plus 7x plus 6 over x squared minus 1. So before you even begin, you need to make sure that you have factors, because the only way that we can simplify with multiplication is by simplifying products. And in this case, we don't have products yet. We have one product here, but the other three need to be factored. So the very first step is factor. And sometimes by factoring, you're going to start to see some different nice things that happen. So I did give you 3 different scenarios for factoring. This one's the greatest common factor. This one's your traditional diamond and box, however, nicely our leading coefficient's 1, so we can shortcut it. And then this is the difference of 2 squares. So constantly look for those different pieces when you have to factor. So we're going to factor out the x, and we're left with x plus 6. In the denominator, I'm just going to write 2 of those out, because that's what it means to square it. So x plus 6 times x plus 6. In the top, we do our diamond and box. So that's x plus 6 and x plus 1, because our product is 6, sum is 7. And then the bottom, it's the difference of 2 squares. So x minus 1, x plus 1. So right from the very beginning, I can see what values x cannot equal. So it might be a smart idea at this step just to write that, so you don't lose them as we start to simplify. So what can x not equal? Whatever makes our denominator equal to 0, because it's dividing by 0. Again, we can't divide by 0. So for this one, even if you can't see, just set them equal to 0. So for this one, it would be negative 6. For this one, positive 1. And then for this one, negative 1. So knowing in the end, if we lose any of those, we do have to state them in our final answer. Okay, so now that we've factored them, typically what you're going to do from here is now write it as a single fraction. Now, some of you might not write it as a fraction. You may just go into the simplification form, but trying to help you keep track of the difference between addition and subtraction and multiplication and division. So writing it all as one fraction, this is multiplication, this is multiplication. So all of our multiplication goes across the top, because that's how we multiply fractions, straight across the top and straight across the bottom. Our next step is then to find those forms of 1 attached by multiplication. So find forms of 1. And again, it really is the giant forms of 1, but realistically, it's doing the exact same. So I just rewrote this out, and now I'm going to simplify out my forms of 1. Here's a form of 1, here's a form of 1, and here's a form of 1. Make sure it's an actual form of 1 and not negative 1. If it's negative 1, that's fine. You just have to make sure that you remember that there's that negative 1 that's out there. So now that we found our forms of 1, we can go ahead and rewrite it simplified. So on the top, we're still left with x. On the bottom, we're left with x minus 1. Super common mistake is to want to cancel these x's out. But if you're not sure, put a number like 7 in. So 7 over 6, so 7/6 versus negative 1. They're not the same. Okay, now going back to what x cannot equal, we said it can't equal negative 6, 1, and negative 1. So when we look at this problem, we do not see all those values. Therefore, we have to state the ones we do not see anymore. So x cannot equal negative 6 still. It also cannot equal negative 1, because again, those are the 2 that canceled out. I can still see that it can equal 1. If I want to write, I can put 1 there too. It's not wrong, but I can still see them in the denominator. So just for ease, you can just go ahead and write the ones that you no longer see. So that is multiplication, about the most straightforward operation with rationals. Okay, now let's go to the left sheet of paper. And now we're going to do division. So just like before, I'm going to leave this open, and I'm going to start my problem over here. So x squared minus 4x minus 5 over x squared minus 4x plus 4 divided by x squared minus 2x minus 15 over x squared plus 4x minus 12. So just like we needed to earlier, we're going to have to factor. But before we factor, I recommend taking care of the division. So by definition, change division into multiplication by the reciprocal. So again, just the definition of division. So that becomes x squared minus 4x minus 5 over x squared minus 4x plus 4. Change division into multiplication by the reciprocal. And then from here, go ahead and factor. So why don't you pause this for a minute and see if you can finish this up, because now once you have it at this step, it's exactly the same thing as multiplication. So here are the factors. And then again, at this step, if you would like, you can write what x cannot equal. Again, it's not wrong if you don't. You have to just take it in consideration later on. So where am I dividing by 0? At 2, at 5, and at -3. Now keep in mind, we're talking about we can't divide by 0. So it's hard to see that up here. So once we change it into multiplication by the reciprocal, it's usually a little bit easier to see which values you can't have. Okay, so then from here, just like last time, we're going to go ahead and write them as a single fraction. And since it's multiplication, we multiply straight across the top. And then straight across the bottom. Next, we're going to go ahead and find forms of 1 and simplify those out. So we have the x minus 2's, we have x minus 5 over x minus 5, and that's all we have for simplifying out. So then we're going to rewrite in simplified form. So on the top we have x plus 1, x plus 6. In the denominator we have x minus 2 and x plus 3. Don't forget to write what x cannot equal. Looks like we lost a form of 1 here at 2, but I can still see 2, so I don't have to write 2. But the one I no longer see is the 5, so I have to write x cannot equal 5. This is perfectly fine to leave your answer. If you really want to expand it, you can, and then you get x squared plus 7x plus 6 over x squared plus x minus 6. Again, listing out what x cannot equal. However, you don't have to do this extra work. It's just more places to make mistakes. So what did we do? Factor, if it's division, change division, multiplication by the reciprocal. Factor, find forms of 1, and then don't forget to write which ones you no longer see.